All right. Well, welcome everyone. We are going to give everyone a few minutes here to start rolling in. I believe as we switched over to the live webinar, we had some people drop off, but it looks like they are coming back in. My name is Mike Booth. I'm the technical director here at Inorganic Ventures. We have a great presentation or presentations. First up, we are going to have Michael Howe from CEM. Then it's going to be Mike Friss from GFS Chemicals. And then Randy Mercurio from Glass Expansion is going to finish to give a chance just to take care of some housekeeping items. If you're new to Zoom or new to our webinars, you'll see that there is a chat box and a Q&A box. So at any point during the presentations, if you have a question, please use the Q&A box. And what we'll do is we're going to answer all questions at the end. So after Randy's presentation, we'll start going through all the questions that were submitted so far. So please don't be shy about submitting questions during the presentations. We'll get a chance to answer those at the end. This is the second of three webinars that we have planned early for 2025, all about ICP Alley and PitCon 2025, sort of the lead up, the countdown to ICP Alley at PitCon 2025. So I mentioned it briefly at our last webinar. If you're going to PitCon, we definitely recommend to visit ICP Alley. It's a first of its kind collaboration between Inorganic Ventures, CEM, Glass Expansion, and GFS Chemicals. We're all coming together to provide a complete start to finish ICP solution in one central hub. By visiting ICP Alley this year, you'll gain access to all of our expert guidance, some practical tools, and some exciting extras. One of the highlights is going to be the ICP Alley Challenge. If you visit all four of our booths, you'll get a plasma pass, just like a little card at each booth. If you get all four cards, you sort of collect them all, and then stop by and to our Plasma Pavilion. You can turn all your cards in for a show exclusive ICP toolkit. So the Plasma Pavilion is going to be located between the Inorganic Ventures and it's basically a little coffee bar where you can set up, get some coffee, recharge your phones, talk to the folks that are going to be there, network a little bit. It's going to be a great stop. And like I said, collect all your plasma passes and get your toolkit. If you need personalized ICP support, make sure to book a free consultation with some of the chemists from Inorganic Ventures that's going to be there. I'll be there. And then Micah, if you are familiar with our ICP or our custom solution quoting, you might have talked to Micah before. Micah is going to be there as well. And we have opened up our calendar. So if you want to talk with either one of us, feel free to book a 15-minute talk. That way you have it on your calendar and we sort of know what to expect. So I believe that our team will have links available for the here at the beginning. So let us know if you are planning to come to PitCon this year. We hope to see you there. And I think on top of everything else, we have a couple other things for PitCon, just a couple technical presentations. So the first one is going to be on Sunday. It's called What's in Your Chowder? That is being put on by CEM. That is, a free symposium to come to. I believe CEM is going to be there. I'll be there from Inorganic Ventures. And then Glass Expansion is going to be there as well to sort of talk through on seafood samples or anything that's really what's in your chowder. So a lot of good tips, even if you're not doing food testing. And then and one of the short courses that is for ICP mass spec triple quad method development. That is being taught by one of our close collaborators, I would say at this point now. His name is Ben Puffer, and we'll have the links available if you want to register for that short course as well. So I think that'll be a great short course. And if you want links to that, I would say check it out. We just did a LinkedIn posting that had the links to both of those if you're going to be at PitCon this year. So without further ado, I'm going to pass this off to our first presenter here, which is going to be Michael Howe from CEM.
All right. Should be good. Okay. All right. Good morning, everyone. To collaborating with you and the other vendors, GFS and GE at PitCon, and definitely come visit us at ICP Alley. And as Mike is iterating, is kind of going to be a balance to analysis kind of visit. So we kind of want to give you the full run of from your sample prep all the way through your analysis and everything in between. So I'm going to go ahead and get started. And the first thing I'm going to do is try to advance my screen. Okay, one time. All right. Okay, so we do microwave sample. How do we even digest samples? So as you know, with ICP, OES, and mass spec, the measurements take time. And what we need is homogeneity so that we have a nice steady signal in order to do the analysis. And at the end of the day, and no matter how you want to put it, it's kind of cheesy, but the solution is a solution. So I need to be able to give you a proper solution so that your ICP can analysis. Why do we do pressurized digestion? Well, this is a very vessel system because we're able to elevate the acids of elevate the temperatures of our acids. And what this does is it raises the oxidative potential of our reagent. So many years ago, when I first started doing was hot plate and peroxide and even a little bit of perchloric acid at times. Now we're able to take nitric acid upwards of 250 degrees and it becomes a very nasty oxidizing agent to put stuff into solution. Microwaves are also pressurized is also faster. And one of the things that we'll talk about with contamination and crossover is, we're not worried about things being uh, in a hot plate or a hot block sitting beside each other. One, they don't go dry. And we're going to use less acid, but then also the cross contamination between samples because everything is sealed up. All right, so why do we digest samples? Why pressurize? And so why are we doing microwaves? Well, much like your microwave at home, we use it because it's convenient and it's fast. So by harnessing the closed vessels and our active controls, we're able to effectively digest your samples rapidly with high throughput. You get a rapid cool down. And again, we're saving money because we're using less acid. And we're not going back and forth across a hot plate or a hot block and having to add reagent throughout the digest. Most digest from beginning to end, ramp, hold, cool down in a large multi-mode cavity is going to be well under an hour. And now you're ready to go and being able to digest anywhere from one sample simultaneously. And so um, what we're doing is we're only heating the reagent and the sample. So we'll take a look at that. And went back one too many. All right. So in my 20 plus years at CM, this is actually one of my favorite slides simply because it shows in a hot plate, you've got a resistive wire that heats up a ceramic plate, that heats up a beaker, that then heats up the acid, then your sample. And so we have this large transfer of energy, very inefficient. And you're talking about contamination, carryover, if everything's not cleaned properly, but then also you're going to go to dryness. And who doesn't love walking up and down and trying to pour acid into a very hot plate or hot pot? With microwave heating, and we're using the physics of microwaves. And so essentially the acid and the sample itself are attracting all the materials that we use are transparent to that energy. So we have that localized superheating. So we're only heating the sample. That's why we're able to do things so rapidly compared to your traditional method. So now let's talk a little bit more about sample preparation. And these are some of the things, these are just really reminders. And these are things that it's always good to remind ourselves because it's easy to get in a rush, to not take proper care of how you're sampling, making sure that your water, your other materials, that you have a clear uh, right now. So when it comes to the homogeneity of the sample, we all know that this is a very key and very important part when it comes to getting a proper digest. But it also helps in the not contaminating it. Okay, so when we are sampling materials, we're going to be using non tools. Um, Obviously, when you are, say, you have a sample that needs grinding or crushing because we want to increase the surface area because it's much easier to get an effective digest from a powder than it is to like a solid, some sort of metal material that you're trying to digest. So when we're grinding or even using a Morton pestle and or other types of cryogenic grinders, we want to make sure that we're using materials that aren't going to interfere with the matrix and also with if you're looking for nickel and you're using a nickel alloy or something to crush your sample, well, you're probably going to have problems. And so another big part is reagent purity. And our friends at GFS will be able to talk about this in more detail. We use a lot of their acids here when we do our low level work for customer samples and for uh, presentations and generating data. So, what an awareness of the levels of analysis are going to dictate what kind of acid you need to use as far as its purity level. And in today's world, just about everybody is looking at ppb and lower. So, we need to make sure that we are at minimum at trace metal grade or a distilled or the ultra pure that you can buy from GFS. We actually in our facility, we actually use a lot of our own distilled acid where we will take an ACS trace metal grade and actually distill it down as well as the ultra pures. And these are all ways to limit background and any possible contamination in your analysis, especially when we're looking at such low levels. So again, none of this is, rocket science to you all. It's just nice reminders that in every aspect of what we're doing, from ballast to analysis, we have to take care. Water, this again is a no-brainer. We've actually had labs having issues with particular metals, and then we find out that their water source, the water is going through metal pipes, so obviously they're going to have an issue. But I feel most everyone joining us is using an 18 mega ohm type, what's known as the ASTM type 1 water. And this is what you need in order to ensure your lower background values so that you can get really good analysis for your low level work. All right, so another one is the glassware. Everything needs to be clean, obviously. Um, and this also includes tools. We soak our ceramic spatulas and pipette tips and everything whenever we're doing extremely low level work. Everything needs to be non-metallic as we're measuring for metals. The digestion vessels need to be clean as well. Most of your digestion vessels, whether it's CEM or another vendor, are going to be made of some sort of uh, like PTFE, TFM, PFA, and also some quartz. But every one of these need to be cleaned prior to doing your microwave sample preparation. And we're going to start off by debrising any material, and then again, much like the acid choice, The level at which you're doing your analysis is going to dictate how much you need to clean. And so we will definitely be able to provide you with tips and pointers on that as well when you swing by ICP Alley. Clean work environment, okay? Construction, making sure that you've got clean tiles in your laboratories for the dust, and pay attention to your ceiling tiles. They're a good source for calcium. We know because that happened to us as well. What we wear on our persons, from deodorants and perfumes, other cosmetics, you know, zinc and titanium and silicon dioxides in there. So be careful of those. Making sure that we are wearing our lab coats and our gloves as well, to make sure that we're not contaminating our sample with what we're wearing on our person, which then takes us into jewelry, cigarette smoke, using those sticky mats, and routinely wash your lab coats. They have to remind me of that a lot here in our lab. All right. Don't forget your balances and your grinding equipment and your pipettes as well, not only from a static charge for your balances, but also from um, cleaning them, but then also with your pipettes, making sure that you are using proper technique and not taking a standard out, releasing your aliquot, and then dumping any back into your standard bottle. Again, a source of contamination. And then acid chemistry. And this is something that we'll be glad to talk with you about in more detail. So not only from the fact of the level of acid that you use for its purity, but being aware that if you don't choose the right acid, you won't get a complete dissolution. You can use the wrong acid and digest it for 2 hours and it's never going to go in. And then in little things like being aware of some acids will passivate when you're doing some metals and creating that insoluble oxide layer. These are all things that we can help you with as well as we're going through ICP Alley to talk about our common acids. And this is something that we have and provide. Swing by. This is a interactive periodic table, and it's color coded for solubility with the different acids and the elements on the periodic table. And so again, just basically microwaves are going to help us prepare our samples rapidly, completely, and safely. Practices with our cleanliness and not using metallic tools. And as always, if there's ever any questions, always reach out to your microwave and your ICP vendors for support. And that's it.
Awesome. Well, thank you so much, Howie. We are going to hand it off to our next presenter. So that is going to be Mike from GFS Chemicals. Just a reminder, if you have any questions, please post it in the Q&A box. We have some questions coming in, and we will respond to all the questions at the end. So I'm going to go ahead and hand it over to Mike.
All right, we're just setting up my screen. All right, thank you, Mike. I don't know if Randy has considered changing his name to Mike or Michael, but it might be something to help the synergy of this presentation. As was mentioned before, I'm from GFS Chemicals. I'm one of our quality managers here, specifically for our high purity acids. And today we're going to talk about your labware. Howie touched on a lot of the little elements that we're going to talk about here in the next few minutes. There's different types of labware that you can do, but making sure that it's clean, the most important things you can do. So I also like to start off with some of the basics. When you get that result from your ICP, what is it telling you? Ideally, it is only going to give you results from your sample or whatever matrix you're trying to digest. But there's also going to be water and acid in there. If you're getting clean enough of both of those, that should be very little contribution. It can also possibly be not a high enough of his slides that you're going to see a higher background of certain elements. So making sure you have an appropriate grade acid and water in your analysis is really important. The fourth thing here, containment vessels. That's what we're really going to talk about here. That's your labware, any tubing, your sample introduction, which I know Randy is going to talk a little bit about, depending on what type it has, where you'll have interferences, um, and then some non-contact portions of your environment. As Hallie alluded to, you can get things that travel through the air and contaminate your sample. Most of those are more concerns once you get into the PPT range, though. So when you're looking at your labware, everything that your sample or your acid or any of your solutions are going to touch, you're generally looking at some type of glass or plastic. While Hallie's slide says no glass, I consider tends to be a very clean material. But at any rate, the quality of your glass massively affects the level of contamination that you're going to get for it. It tends to be low carryover, so it's not a bad option there. But if you don't have a high enough quality glass to begin with, you're going to see a higher background of some elements. They're also kind of fragile, and they can't handle all the acid types. So if you do need to work with hydrofluoric acid, not going to be a viable option there. When you're working with plastics, which is what a lot of labs have, it's what we have in our lab. We actually have both quartz and Teflon and some HDPE, LDPE. Most of our products come in HDPE or LDPE. The polyethylenes, they can be durable, they can be cheap, they're compatible with pretty much all of your acids. They do lack a little bit of long-term stability, which is why they're not as common in your actual beakers, flasks, things like that. So a lot of your reuse things are your Teflon. They can be highly compatible with everything, though they do tend to be on the little bit more expensive side, which is why they get reused. When we talk about cleaning them, this can be after repetitive use, or it can also be when you first get them. We call it leaching. We want to clean up and leach out all of those metals from things. With glass, that doesn't really happen. Whatever your starting material, whatever its structure is made out of, you're going to slowly, and it's going to remain pretty consistent, which is part of the reason how we said beware of glass, because if you're not getting a high enough quality one, it's never going to get better. But when you get something like a high purity quartz, which I know there's becoming more and more vessels available for that, particularly as PFAS becomes more of an issue for places. We're trying to reduce that. High purity quartz can be as good as anything. We are able to get many results in the parts per quadrillion when we're using our quartz labware in our lab. For plastics, your HDPE, LDPE, they're going to be, again, starting is going to be dictated by the resin source, the area of manufacturing. But generally, you can always clean up plastics. It just takes more repetitions, more clean outs. But for the most part, it'll always get there. Lack some long-term stability with your strong acids. They'll become brittle. Generally, a couple of years is all the longer you want to use those. Otherwise, they can become a little bit dangerous depending on what acids are being held in there. They also struggle a little bit with transpiration, particularly with HCl. You'll get this dusting, coating of HCl that actually works its way through the plastic, through the pores, and can cause some problems there. But when it comes to cleaning them up, it's going to be the same general trend with whether you're doing plastic or glass. It's just the number of repetitions and how you're going to use some sort of surfactant on them initially, get off your organics, get that out of the way. And then you want to be either leaching it or rinsing it with some sort of dilute acid. The cleaner you want it, the more repetitions of that dilute acid you may need. And I highly encourage people to condition their plastic right before using it. Whatever solution, acidic solution they're about to put into it, just give a quick rinse from that. It gets those most common elements that are going to come out in that solution out and rinsed away before you ever touch your sample. The other type of plastics, which I'm sure a lot of people are familiar with, your Teflons, your PFA, FEP, PTFE, stuff like that. Similarly, like I said, resin source, manufacturing process highly dictates what you're going to get out of that. Typically, most of the time, you're going to get a handful of elements right around a part per billion. If you're not conditioning it, we have seen some manufacturers get most metallic elements down to the parts per trillion, single digits before initial use. So they require iron and aluminum. Those will pretty much always need to be leached out before use. They're great for long-term viability. They don't have the same brittle issues from long-term use that HDPE, LDPE has. They still, though, particularly with hydrochloric, you'll see cloudiness of the bottles and some scarring, some like textured to the outside of the bottle if it's above that 37% or it's been in there a really long time. But again, cleaning them, same process. You just may have to do more of it to get down to those lowest levels. The plastics versus the glass, they are more prone to wider concentration ranges, wider contaminant ranges affecting them. So if you're normally working in a 1 ppb range and then all of a sudden you have a sample in there that's 10 ppm, you may continue to get contamination out of that plastic for days or weeks sometimes, as your plastics are much more fluid than most people would think. You'll see as they heat up, as they change out solutions, as they cool down, those little pockets and pores that are in the plastic will trap levels of contamination and then open them back up during the next sample. If you're not sort of contamination range. And here you can kind of see the chemical reaction. Your samples when you have those sodium atoms here trapped in our fluorinated plastic. If you put in something like nitric acid, you're going to see the nitrate ions that are floating around in solution start to pull those sodium ions out of the plastic and attach to them and start to clean up that plastic long term. It's the same process, what's called a mash reaction. You're going to have a metal, an acid, and then it creates a salt and hydrogen. Typically, it's going to be in solution, so you're not going to actually get hydrogen gas. It's still going to stay dissolved as hydrogen. But basically, it's creating that salt because it wants to pull that rather than leave it there in that plastic, because there's just that strong draw to metals. And I just want to kind of wrap up. Big takeaways from this should be that I want people to be more familiar with their labware. A lot of people come into a lab, everything's there, and then you switch out to the next person, stays the same. Nobody's really challenging what may be happening to that labware, or the fact that the industry is over the last decades that it's only going to need higher and higher purity, that your cleaning procedures from 10 years ago may not be adequate if those procedures aren't being updated regularly. And as always, I'm sure a lot of people here help. Collaboration is one of the greatest things that we can have for solving problems. That's why all the presenters are here. We love doing this, and we hope you guys will reach out. If you do have any questions, you want to reach me directly, my email's mvirus@gfschemicals.com. And I'll be happy to answer any questions after our presentations. So I'll hand it back off to Mike, and then we'll keep moving on.
Awesome. Well, thank you, Mike. Yeah, that was a great presentation, and those cleanliness tips are always great to pass along because yeah, in the world where everyone's looking for lower detection limits, that can be a challenge. So last up, we have Randy from Glass Expansion. And just a quick reminder before Randy starts with his presentation, if you do have any questions, make sure to submit them in the Q&A box. We are seeing more and more questions, which is great. And we will answer those directly after Randy's presentation. So Randy, I'll hand it off to you.
Thanks, Mike. Good morning, everybody. Thanks for joining us this morning. I'm Randy Mercurio, the ICP Technical Specialist at Glass Expansion. And I'm going to tell you a story about a lab that was able to improve their washout and efficiency by up to 61%. But first, just an overview of the outline. If you're not familiar with Glass Expansion's products, I'm going to give you a quick introduction to Glass Expansion and the products we supply. I'll go over spray chambers and their role in the sample introduction system, explain a little bit about the designs and advantages of Glass Expansion spray chambers. And then I'll give an introduction to the PCC kit, or Peltier-cooled cyclonic spray chamber kits we offer. And I'll go over quickly how the performances of that kit by showing some instrument and method performance reports operating with the PCC kit. And then I'll present a comparison of some real-world data of boron washout using the Scott-style spray chamber versus the PCC kit. And then I'll conclude by just giving some key benefits of what you'll gain by using a PCC kit. Glass Expansion's been manufacturing ICP components. We have products that supply just about every major manufacturer and model of ICP OES and ICP MS. We supply all the different types of products you see here on the left. In addition, we have optical windows, laser ablation adapters, and things of this nature, some tools to improve performance, and some performance enhancing accessories as well, like the PCC kit that can optimize some analyses. We have many educational resources. We have a fully equipped research and development lab located in Australia, a bunch of expert technical staff to assist people. And on our website, you'll find lots of product flyers, newsletters, instruction manuals for the products, application notes, and even catalogs that can help you find the products that are best suited for your instrument. We also have videos and webinars like this one that you can go to the website and find when you need some resources. They come in many different shapes and sizes, and I just want to touch upon those today. On the top left here, we have some single pass spray chambers made out of glass. And on the right are some double pass or baffled spray chambers that have this center tube that come down. That's how you can tell a double pass from a single pass. And sometimes you may need to use a PTFE spray chamber or PFA like this one on the right. These are typically reserved for analyses containing hydrofluoric acid or perhaps ultra trace metals analysis. This is our ISOMIST XR, or extended range temperature controlled spray chamber. It can go down to -25 degrees Celsius and up to +80 degrees Celsius, and that has specific uses for many different types of applications. But today I'm going to focus on the PCC kit and how that's useful. But before I get into that, I just wanted to go over some of the designs and advantages of glass expansion spray chambers. When you're using a spray chamber, sometimes it's an overlooked item that can cause some problems in your analysis, such as loss of sensitivity, poor precision and accuracy, sometimes signal stability. And sometimes spray chambers can cause dead volume, which means in some areas of the spray chamber, liquid can pool, causing excessive washout times. So they do have a profound effect on transport efficiency, precision, and washout. And so you should really consider the type of spray chamber you're using and the design of it when you're trying to improve your analysis. Glass expansion spray chambers come with this Helix CT or constant torque locking screw and seal to chamber. The Helix CT gets all the drawbacks of O-ring seals, and it improves user safety by preventing broken nebulizers, which can be expensive. And by using this ratchet mechanism, the locking screw spins inside the spray chamber, and when you get to a certain point, it'll ratchet and click, and you'll know that you have the proper seal on the nebulizer. The other benefit is the Helix locking screw has this positive stop, which allows you to insert the nebulizer to a fix by stopping at the nebulizer argon gas arm here, and it positions the nebulizer perfect depth to get optimum sensitivity. In addition, that constant torque pressure, when you ratchet that locking screw, it applies the proper pressure to get optimum sensitivity with your nebulizer. If you over tighten, you may end up reducing your sensitivity, which is not optimal. And as we were saying, the Helix CT can provide an improved washout, and you can see the Helix interface washes out a little more rapidly than something that's a non-Helix interface spray chamber, for example, something that might have a couple of O-rings in the nebulizer insertion area. This is our PCC kit, and it allows you to switch from the standard Scott-style spray chamber on an Agilent ICP-MS to a Tracy spray chamber, which is a cyclonic version. And these have a little better washout by their design. So we already talked about the washout efficiency and the Helix CT interface. And the other advantage of this is that you can interchange spray chamber materials. As you can see on the right, there's a version of glass, quartz, and PFA. All can be used with the PCC kits. Glass is great for routine analysis if you're not doing low-level boron. If you are doing low-level boron, you're going to want to go with a quartz spray chamber or PFA. And the PFA is usually reserved for hydrofluoric acid matrices or sometimes ultra-trace analysis by ICP-MS. You can see the brown coating on the inside of this spray chamber. It's a steady flow surface treatment. What it does is it improves the wettability of the PFA material, and it basically helps with efficient drainage, giving a similar drainage ability to that of glass. So the PCC kit can be installed really simply. It comes directly with the attachments to connect to the communication port and the water cooling system that's already existing with your Agilent ICP-MS. And it comes with a nice mounting bracket that allows you to swiftly install it with just replacing the bracket that's there with the one that we provide. The PCC kit also has a JVI or jet vortex interface. This is an aerosol filtration fitting that mounts on top of the spray chamber. I'll show shortly, but it's compatible with the HMI and UI features of the 7850, the 7900, and 8900 models. PCC kit comes basically with 3 different models. In the middle here, we have a mounting plate that allows you to use a switching valve. Basically, this one's specifically designed for the Agilent switching valve. And I'll show a little more of that in a minute. The one on the left is also available for the 7850, 7900, and 8900. In this case, you would use this if you don't have a switching valve. However, it can be used with other OEM switching valves if you do have something else in operation. On the right, this is a PCC kit that is available for the 7700, 7800, and 8800 models. And all of these spray chamber designs can be fitted into the PCC kit. So they're capable of taking glass, quartz, or PFA spray chambers. So this is an example of a setup with the PCC kit using a switching valve. And we went over all of these kind of features already. I'll just note that it is compatible with the AVS auto dilution system and the integrated sample introduction system. And cooling, as I said, it operates directly with the software, the Mass Hunter software that's already on mounting bracket. And you'll notice the nebulizer path length is quite short. It's a very nice short length to help with rapid washout time. And it definitely helps with troublesome elements like boron, mercury, even lead and antimony, and some other elements that are sometimes taking a little longer to rinse out compared to the Scott style spray chamber. So this is a little bit about the JVI. This is the jet vortex interface connector, and it basically sits on top of the spray chamber in the PCC kit, and then the transfer tube sits on top of that. And there's a little port on the JVI that takes this gas fitting, and that connects to the dilution option gas to provide the gas supply to the JVI. This is an Allegra argon humidifier. And what it usually does is it humidifies the gas going from the nebulizer and or to the JVI, because the gas supply coming into your instrument has a super dry setup. It's got very minimal water in it, and that can cause a lot of salt buildup. So by humidifying the gas going into your nebulizer, and in this case also the JVI, you can reduce the salt buildup on your interface cones. It also helps with things like the tip of the nebulizer, your injector, and even the outer tube of the torch. And so it's going to help improve the stability and long runs, and even it might take a little longer for you to have to even replace parts or maintain them and clean them. And this Allegra argon humidifier is compatible with the Scott style spray chamber and the PCC kit. So the PCC kit can be used with many different types of our nebulizers. It's commonly used with the micromist. It's calibrated for use with the UHMI, and some analyses may require a sea spray nebulizer more than 15% to go with the sea spray, because it can handle up to 20%. And then if you're even doing more than that, you can go with the Duramist, which can handle up to 30%. But these inert nebulizers here, the Duramist and Opalmist, are typically reserved for hydrofluoric acid analysis, or in the case of Opalmist, for ultratrace analysis. So now that you know a little bit about the PCC kit, I want to share with you this customer success story. It was a high throughput environmental lab analyzing high boron concentrations in some samples, and they were looking for a way to reduce the excessive rinse out times and then get better quality data and improve their sample throughput. So they were using an Agilent 7900 ICP-MS with the Scott style spray chamber, the ISIS switching valve, and an SPS4 auto sampler. And they would run their Agilent performance report after the thermal stability to make sure the instrument was within operating parameters. And because they were using EPA method 6020 to analyze these samples, they would also check the hydrogen mode and helium modes to make sure that the nebulizer and JVI settings were providing a good optimal operation conditions and passing that report as well. So the challenging real world sample was an aqueous sample from a remediation site. It had about 4 ppm of boron in it. To collect washout analysis data comparing the Scott style to the PCC kit. This lab typically had to run 10 blanks after a sample like this to get back down to their reporting limit of 10 ppb. So here's the instrument performance reports, and you can see the nebulizer gas flow is typically about 1.04 liters per minute. And at this point, the JVI and the gas flows for the helium and hydrogen are not turned on at this point. You can see the sensitivity counts, RSDs less than 2.5%. The oxides and double charge less than 1.5%. This is an average of 15 performance reports. This is an example of the hydrogen mode. At this stage now, the nebulizer gas is set to 0.85, JVI dilution gas at 0.15, and the hydrogen flow at 3.5 mils per minute. And you can see the sensitivity in RSDs. RSDs are less than 2.5% here for the masses that they were checking. And here's the helium mode, same situation. The nebulizer and JVI gases remain the same. Helium gas is now at 4.5 mils per minute. And you can see the sensitivity and RSDs here all less than 3%, many of them less than 2%. So this is the actual analyzed. Here's the Scott style spray chamber data on the right, PCC kit data on the left. And they would run the sample and then they would have to run 10 blanks to get down to below 10 ppb, their reporting limit. This would normally take about 31 minutes for them to get through that time frame, whereas the PCC kit was able to do it in about 12 minutes. And this is the data graphed. You can see the Scott style spray chamber versus the PCC kit was able to get to the reporting limit, and then the Scott style took the 10 rinse blanks. This is significant. It's a 61% improvement in the boron washout time, so it resulted in a much higher throughput and much lower potential for any carryover while they were analyzing these kinds of samples. Just to summarize the PCC kit benefits, you're going to get faster washout times compared to the Scott style spray chamber. It significantly reduces times for the sticky type of elements like boron and mercury. You're going to get a more efficient workflow, less reruns from unanticipated carryover or poor RSDs. And then you get an improved signal stability as well, because there's reduced memory effects lead to more consistent and accurate measurements overall. And then you're going to get longer analysis times with less analytical drift. You'll have higher quality data too. So less data flags on things like instrument blanks, method blanks, and so on, and any other QA/QC samples you may be analyzing throughout your analysis. And then your greatest advantage is you get an increased sample throughput. Now, why waste time on blanks if it's not necessary? You're going to have faster uptake and washout times, shorter sample acquisition times, and also increase your sample throughput. If you'd like a free review of your sample introduction system, I'd be happy to help you out. Please contact me by email. It's rmercurio@geicp.com. And I can help overlook your sample introduction system to see if there's ways we can improve your performance. If you're having any particular challenges in the lab, maybe you're interested in learning a little more about the PCC kit. We can also explore ways to reduce your operating costs. And if you need any quotes, I can provide those as well. Thank you very much. And I believe we'll have some time for some questions now.
Awesome. Thank you, Randy. Yeah, we are going to get into questions here. So again, if you have any questions, feel free to use that Q&A box. But we are going to go ahead and get started. And the first one up, Howie, I believe this one is going to be for you. Marlene says, I'm relatively new to microwave digestion and ICP. If there are issues with an incomplete digestion, how do you determine if it is the microwave is malfunctioning or if the vessel is deteriorating?
Okay, that's a very loaded question. It's something that will, this is obviously where we would definitely be a good resource for you to call in. But some of the things that we would want to find out first is, have you ever been successful with this digest, and what determines your success? Is it recovery? Is it the color and the clarity of the sample at the end of the digest? Was this a change? Have you seen a deterioration of your results over time? All of these things would lead us into the direction of, are we looking at vessel components giving way? Do we have some sort of hardware problem? But a very specific short term is also we can do a variety of spikes in our samples and also a post-digestion spike as well to help alleviate, is it from the sample prep, or is it from the ICP side of things as well? So there's a variety of ways to attack this, and this is where we would really, be able to help you one-on-one issue may lie.
Great, thank you. Next one, Mike, I'm going to find one for you. This one came in from Christopher during your presentation. And he asked, how about carryover with HDPE and PTFE containers?
So you're going to see some. It's going to be similar to your Teflon type products. You're always going to see it as long as you're within the prior samples within roughly an order of magnitude, it wouldn't be a huge concern. Glasses, especially quartz glass, is going to be better for reducing that carryover. But again, it's why I emphasize that if you have higher levels of contamination in a sample, that may be something you're wary of for follow-up samples. So HDPE, LDPE are going to be able to store and have some of that carryover.
Got it. Thank you.
Mhm.
Randy, we had one come in from John. They asked, is there a benefit to using a plastic spray chamber when testing impurities working with high metal alloys?
It depends partly on what your method goals are and what you're trying to achieve. If you're looking for lower level background, perhaps it depends of this nature. If you'd like to give me some specific information, feel free to email me the details and I can go over what might be the best option to analyze that particular type of sample and what your method goals are.
Great. Howie, I'm going to go back to you.
Okay.
Melissa has an interesting question because we know things just never go right all the time in the lab. She's asking, how would you digest an alternative?
Okay. So we're talking about using a hot block or hot plate as a backup.
Yes.
Okay. Wow. All right. Well, let's go in the Wayback Machine. But no, seriously, at this point, one of the things that I was talking about during the presentation is that with a closed vessel microwave, you can really harness its pressurized capability, and that's why we can really excel with nitric acid as an oxidizing agent. Now, in an open vessel environment, now we're going to have to lean on reagents such as peroxide to aid in our oxidation, because remember, in an open vessel, all right, we're only at ambient pressure. We're only going to get to the boiling point of our reagents, which then brings me to another example or another point is that you may have to incorporate sulfuric acid, because sulfuric acid is such a high boiler, it allows us to raise the temperature of our digest in an open vessel environment. However, I would be remiss if I didn't mention if you're doing sulfuric acid, you've got to be aware if you're analyzing for either barium or lead because of insoluble sulfates. So with a hot block, hot plate, you're going to require more reagent, more time, so be patient. And then also you may have to change your acid chemistry, and that was probably the biggest takeaway is that you may have to change your acid chemistry.
Great. Thank you.
Hmm?
Mike, I'm going to send this one to you. I think this one came in maybe between presentations, but I think this would be a good question for you. And asking if even if glass is autoclaved, I think it's more of a concern about the cleanliness of the glass. So autoclaving glass, does that do anything in terms of contamination?
I mean, it's gonna remove some of your organics, but that's really what that autoclaving is targeting there. Whatever your glass is made of, it's not gonna. So that's likely not going to improve much from a contamination level from that you're getting from the glass.
Okay. Thank you. Randy, we have a good question. I need to find it again, but it was essentially about how to tell if the nebulizer is over tightened or under tightened. Um,
Yeah,
yep, another anonymous attendee. So how can you tell if the nut on the nebulizer is over or under tightened?
yeah. Well, with the Helix CT, it basically when you install it, the locking screw gets threaded in with the steel until it comes to a soft stop. Then you insert the nebulizer and you ratchet the locking screw just enough till you hear it click. And once it clicks, you know that you have the optimal seal on the nebulizer. And if you just gently pull on the back of the nebulizer, it shouldn't come out. And it's a very, very gentle pull just to make sure it doesn't slide out easily. Over tightening is prevented by using the Helix CT, or using other spray chambers that may have like a O-ring pair in there, you don't know what depth it is and things like that, or if the O-rings are even making a proper seal. So the Helix CT really does ensure that, and you replace the seals on there about every 6 or 9 months to make sure that the seal is proper. But it's not necessary to over tighten with the Helix CT. That's the whole point of it. So
Perfect. All right, Howie, back to you.
All right.
What would be the right way to clean microwave tubes after a run? Do you have any special cleaning tools? And I think this actually is going to answer quite a few of the questions that we've had submitted. So yeah, just basically how to clean the digestion vessels.
Okay. Sure. One of the very first thing is obviously we want to debris. So if you have any non-digested material, or if it was more of an acid extraction or a leach and the solid particles still remaining in the vessel, obviously we want to debris. Then we're going to use typically a phosphate-free laboratory detergent, such as I think we use like the Micron 90 and Alkanox, things of that nature. Hot DI water uh, for the general washing. Now, once we get past that, for, are we good with the hot soapy clean with the proper laboratory detergent with a DI rinse? Next, we could then do a dilute nitric or a soak after we do our soapy wash, then do a dilute soak for 15 or 20 minutes, DI rinse. Then as we're starting to get into like low level PBB and sub PPB, we at this point start to encourage doing after the soap, after the DI rinse, then incorporating a hot acid where we will actually put acid back into the vessels and run in the microwave. So cycle the vessels again, sealed up, just above boiling, anywhere between 150 and 200 degrees Celsius, to add another layer of cleanliness, and then rinse them out with DI water. Now, an important thing with storing these vessels after you've gone through all of the steps to clean them, okay? Because I love the fact everybody wants to be clean, because this is the first opportunity for you to, have real big impact on your results. But when you store your vessels, store them in a plastic drawer, a coated drawer, a plastic container. I have walked into labs and where vessels are laid inside of a metal cabinet and they're corroded because these materials, Teflon is porous. So, some of the NOx gases will still penetrate and reside in those pores. And if you lay those inside of a, okay, those pores will eventually open up, and then you can get gases to attack the metal, corroded drawer. And then obviously now you just introduce possible contamination. So sorry for the long-winded answer, but there's a lot to it than just washing a dish.
Yep. All right, Mike, I'm gonna send this one your way. And this is from an anonymous attendee. We've had issues with cobalt sticking in our system recently. Are there any materials or surfaces that we should pay more attention to? Any specific source of contamination in the lab? We've replaced everything we can think of, and the sample is still showing evidence of contamination. So I know that you do a lot of work, testing the clean acids. Have you seen any cobalt issues?
I don't think I've ever experienced like persistent cobalt issues. Usually that's been some sort of cone deterioration. If we're seeing that, um, if you guys have ever seen anything, I'm not really, never really seen cobalt be sticky. Have you, Howie?
No, not at all.
Okay, yeah.
It's typically, as you indicated, something potentially with the cone if it's got cobalt in it, but not from an environment. It's not an environmentally readily available contaminant.
Right.
Yeah, I was going to say the same thing. If you're on ICP mass spec, I would recommend checking out the offer mass spec cones. Any thoughts on cone materials?
Yeah, I mean, the cones are, I had a case one time where I had persistent cadmium background and I couldn't figure out where it was coming from. It actually ended up being the injector. I don't know how, but the cadmium appeared to be embedding itself in the tip of the injector over time. Maybe it was just an old injector. And so if you haven't replaced the injector, I would definitely take a look at that. You got to determine whether the cobalt's actually, is it a method blank issue from digestion is where you're seeing it, or is it an instrument background issue to determine or isolate where that cobalt could be coming from? If it could be coming from anywhere in the sample introduction system, from the auto sampler probe all the way through to cones. And optical windows can get dirty on ICP OES instruments. Those should be cleaned very carefully every so often to make sure you're getting optimum signal. So there's many different things to check, but the first thing is to identify where you think it may be coming from and isolate whether it's coming from the digestion process or is it coming from the analytical side. And if it's not any instrument introduction parts, maybe your rinse blank is contaminated and you need to clean that vessel out and start fresh. Or the auto sampler rinse station maybe by chance has some contamination in it. And so all those things need to be checked when you're dealing with some persistent background on a particular element like that.
Perfect. And I will say, I know that we are at 10 o'clock. Our panel here has agreed to stay an extra couple minutes. If we did not answer your question live, we will be answering the questions in writing and we will make sure to send that out to you folks. So if you're waiting on your question, I believe we're going to do one more question and then sign off for the day. But you will get your questions answered in writing, and you can always reach out to our presenters as well. So the last question that I'm going to um, go with is from another anonymous attendee, and it's about cleaning. So we have a cleaning, or what type of cleaning procedure would be considered good enough for digesting material such as a screen for whatever metals are present? They do 100 samples per week. Would you soak, and would a soak and rinse approach be sufficient? Or should you always be doing a preconditioned acid run? I believe this might be for you, Howie. It sounds like more of a microwave digestion question.
Yeah, can you repeat the beginning part about what are we digesting?
It just seems like a metal screen. What metals are not defined, but if it's I think they're just wanting to make sure that their majors are out of the container.
To like a hmm. I'm not sure if I'm. Let me see if I could find this question.
Is that
Um,
9:41 a.m. if you're
Yes,
speaking
yeah.
through the
yeah.
open?
Let's see, good enough for that. So, like material as a screen.
And this might be a good question for all of our panelists on this one. So if
Yeah,
anyone has any thoughts, feel free to jump in.
yeah. Digestion light material as a screen. What metals are present?
My
Okay, I
thought would
mean,
be,
it
sorry.
may almost be like they're looking at like a like spike samples or like because they're looking at a like material of what they normally digest.
Yeah, I read this one as I think that they're wanting to know just how would you determine what's good enough if you have a sample type you're running continuously,
Hmm.
and you're just wanting to make sure that those major elements are not, your cleaning procedure is good enough for those.
Oh, okay. Well, then one of those would be to do some blank studies to see whether or not you're getting any type of carryover. You can always, I mean, a blank study is like the end all. This is where you can really take it from the beginning of your digestion process with the same vessels, the same acids that you use, and then take that through, and then to see whether or not you do have carryover after your typical cleaning process. Because that's kind of what we've done in the past is depending on we treat a sample, then run it as a blank after a rinse, then we run it a bling after our hot acid cleaning to see what levels best clean our analytes of interest. So thanks for the clarification. Sorry, I had a hard time picking that up.
That's all right. No, I think that's a great answer. I think I saw Mike and Randy shaking their heads as well. So, yeah, no, that was great. So that was our last question for the webinar. I do want to thank our panelists today for joining us, and I want to thank you guys for sticking around. Like I mentioned, we will answer all the questions in writing, so expect to see those in your inboxes in the next few days. And just thank you all so much for joining us, and we hope to see you in a couple weeks for our last webinar as part of this series. And I hope you all have a fantastic day. Thank you all so much.
Yep. Thank you.
Thanks, guys.